Bueno, buenas tardes a todos. Estamos.
Good afternoon, my friends. We got a hoarse throat. We are under the flu. It's his fault. Let's move on to the presentation very quickly because we're running out of time. We are behind schedule, and so this is a joint talk. Pablo and Chema, we working in Computer Informatica 64 for a long time. We had been trying to do something all together, so we decided on an idea we liked. Pablo, his mission in 11 Path is to try as many ideas, crazy ideas as possible, and let's check them out and see if they're workable. So we put it a sexy name. Toads? Do you like toads? Don't you like kissing toads? Okay. Our presentation is simple for us to understand. I've been working for a long time in this cybersecurity world. Over the past years, I have developed a total discuss about the super mega fashion technologies. When you go to places and about the new technologies and new products in cybersecurity to protect the companies, there is a new word, new coinage, which are super cool. The reality is when we are checking all the cybersecurity incidents in the companies, in the very end, this happens based upon basics. So I type in this reports from dated back to 2015, published. It's a evaluation of DHS Information Security Program for fiscal year. It's a United States organization which recognized that I have systems unupdated. The operating system is not updated, it's out of cycle. Web pages with SQL injection. Oh my goodness, things that in 2016 you should not be hiring anybody. It should be business as usual in your organization. I even have a theory, Frozen maybe. Who many of you saw it? And how many of you don't you have daughters? Oh, you are so tender and cute. I usually in the 11 path office, you can see this drawing from Frozen. I use it to explain people to the people about the cybersecurity guy in the companies. We have the model Anna, model Elsa. Model Elsa, cybersecurity responsible person, full of money. When it has fluff, is his company is full of white dirty shit, and they go to the manufacturer and they buy a castle away from the problem by spending a lot of money, and they say let it go, but they don't fix the problem. They do this in many companies with no Windows updated, but they buy super fashion, super cool technology. Please raise hands if you are familiar with this type of manager. And CCO model Anna, she's penniless, with the problem of resolving the villages problem, and started doing the basis. She climbed up the mountain without worrying on carrying on their shoulders Jesus Calleja to tackle the problems. This being said, in many of the cases in organizations, when we see the incidents, they sneaking in Sony or JP Morgan, when you go to the root, where this dates back, this is a super complicated fucking attack. In 90% of the cases, spear phishing was the origin of the attack. That email sent to an employee's company by convincing him into putting their password there. We talk about machine learning, but the origin is that a password is stolen with a spear phishing. So This can be even easier than speech phishing, and many organizations are not protected against this kind of attacks. Good afternoon, Rooted. In the very end, the problem can be summed up in this phishing, spam phishing, and spear phishing. Phishing is a website where the identity, the access to introduce a password and user or personal data, an account, and we have a spam phishing is a massive use like a dragging phishing, which sends so many huge emails for somebody to take the bait and introduce the data. And spear phishing, for the previous statement, well, you could say, I don't fall into that because they can easily detectable with superfluous data. But spear phishing, everything changes. We have small data such as the personalization of an email or a website against certain user, we can fall in. Notice this email dated back to 2014. You can even think, oh, my name appears on, they know who I am. It must be Apple. Solutions, awareness. Over 15 years, technological companies have taught us not to trust anybody. Never will be asked to introduce passwords, users on the email, or trust websites where the domain does not coincide with the domain of the website sending in the email. Adobe says if we ask you through email, you have to access our domain-based website. Twitter says to us, my emails as Twitter are going to be written with domain twitter.com. And Norton, pay attention, Norton never release confidential data, password users, never give away bank account numbers, and Apple says that we should verify the identity, the domain, the certificate. When we are receiving an Apple-based email, we need to access a site where we can validate the certificate and see a green drawing. This means that this is an amplified or extended validation in the certificate. These technologies educated us on recognizing what is a phishing website, but we have even introduced measures that from the very same browser are anti-phishing filters. So if others is not categorized as a phishing site, you can go through the phishing. These measures are counter active to the point we're trying to sort out. Solution, second factor of authentication is a measure. Theoretically speaking, we had always been using one single factor to authenticate the using of password. When we were installing of the user or password, they can access our digital identity. With the second factor of authentication, we step up the robust level of authentication. To get a robust identity, I need to introduce something I know, user and password, something I have, my mobile phone, on which I receive as SMS or I can generate a DOTP. And the third factor should be that I am. It's what biometrics act. Some companies integrated three factors. It's not that common. We stay on this very second factor. Let's imagine that somebody wants to steal Office 365. How many of you have it on your company environment? How many of you have Hotmail or Gmail accounts? Around everybody got it. Otherwise, you don't have social network. How can your accounts be stolen? Let's focus on Office 365. If I only have user and password, they can, with a Trojan, with spam phishing or spear phishing, they can steal me from my password and useful. If I introduce a second factor of authentication, is slightly bit difficult. If I introduce a second factor of authentication, if I configure an authentication password, application passwords are some tokens of access as a password which are associated with a connection from a device and that are not solicited a second factor of authentication. And applications such as Outlook with an application password could be hacked and stolen from the key container, suffering a phishing attack and having access to the physical device. If I don't have this password application, I only have a second factor authentication with web-based access. It's likely that if I access the network, I can be a man in the middle. In the case of Outlook, the HTTPS policy is not hardcore on the browsers, so a time window is open to be the man in the middle, but it's not that easy. The super difficult one, if there is a second factor of authentication, no application password, and there's no physical access to the network, it could be we are in a kind of complicated environment. The most difficult one, nothing happens. Mess with the best, die like the rest. This is much easier than you think. Why? Because this is what we are going to do. SAPPO speed apps to steal auth tokens. The moment a token auth and an auth token is stolen, nothing worse, nothing. No, there is second factor or other thing. We have a stolen of a token that access 100% to identity provider. You can access it without having access to the second factor of authentication. Let's see how these attacks work. Then, in reality, people have been stolen money from the bank, not because of you fell into phishing. They stole you the auth tokens and they monitor your email without you not knowing this. In few words, auth, what is it? Auth is an authorization protocol. In the very end, we have three phases or stages, three roads. On one side, the application. Secondly, the user using the application with a benign objective. And third, the service provider: Microsoft, Google, Facebook, Twitter. The very first stage, the application tries to redirect the user to a website of the service provider where they are asking for a list of permissions. The user perceives a website of their service provider, Facebook, Microsoft, Google, and the user accepts these permissions. If he wants to give permissions to the application, the moment he gives permission to the application, the service provider is giving us back through the user an auth code. With this auth code, we are requesting from our application to the service provider the access token. And once the access token is in our hands, we can access the identity resources. In very few words, we generate a list, a URL, where we are asking for permissions to the user. The user clicks and generates an auth code, which enables us to access the resources. This is easy. Let's imagine we have companies, employees with any kind of the second factor of authentication. How tokens can be stolen? We first create a malicious application on Office, Twitter, Gmail. Secondly, we create a spear email to get permissions in the target account for this URL, which is one single click. We get that the user does a click, wait vacant to click on yes and validate the auth code. We get the auth code, we get access token using the auth code, and we access through the access token to data, contacts, and emails. This is easy. Phase one, creating the application, a malicious application for this purpose. We're going to this application, the apps.Microsoft.com. Let's create an application very quickly. Is it ready on my computer? This is my application's site, and at the very same time, we create the application on SAPPO. This is our SAPPO interface. Do we have the internet here? Please don't die. So we create a Microsoft-based application. Add an application. You get a new application registration. The name is going to be the female toad, the female frog. So in parallel, created with our site SAPPO. Application ID, we copy and paste the application ID and we put it to register and sign up for our, we generated the secret, generated the new password, the user's application ID, secret is the password. We copy it and we put it on here, secret, where we can drive in the victim into. It's an office application, send it to the office portal, and with an icon, this is icon with the logo from Microsoft, and now we at the endpoint, the place where we're receiving the connection. So now we take our application, which is automatically mounted with this 11-path server, and this 11-path server has to be plugged in with the ID in the very end of it. This is where we are going to put the endpoint to receive everything. We create the application, and on SAPPO, we are going to type in these URLs we don't need anymore. This is it. So far, so good. So it's created automatically. So we have created an application. Benign or malign application depends on how we use it, but this is registered on Microsoft systems. This quick, and from then this moment on, when a user gives permission to this application, we, by identifying ourselves with the application ID and the secret, we can do whatever we like. So we have SAPPO, we have Spotify, and so far. And on our SAPPO, we have created some applications. So far, so we have created an application. Next step, we ask for a scope permission. Permissions are called scope, S-O-P-E, scope. We tackle certain problems with the Microsoft documentation. On one side, we have the API. From the application, we can try to send Outlook applications in order for them to use this API, and through this API, we can access their identity resources for which we have been given permissions. We can access the email. I can tell you about the email, Skype, Drive, contacts, events, and so on. The email issue officially can be accessed, but when you try to access through an Outlook email through the API, they give us an error. We read Microsoft documentation. They are in the process of migration. In the coming future, all the Outlook could be accessed through the API once we have given permissions to it. We try to Office 365. The API is different, but still being used. This version, Office 365, when we tried these accounts, we could access the emails. It's funny. The payer has access through the API. The unpaid does not access it. This risks users at certain moments in time. Let's try again with the API. From Office 365, we can mail read, mail send, mail read write, calendars read write, contacts read write, and contacts read. So far, so good. Let's put the very first petition into detail. Now, the first demo, where we are going to do the emulation and the supplantation. Let's first try the very first petition generated. This is a GET sent to a Microsoft domain in which we can get a list of permission scopes. if we pay attention to the URL, it's a very long one because the scope listing is very long and it's usually on the right. So they are invisible at short sight for users. So we have to indicate that we want to indicate that it's a code petition when the Microsoft is giving the answer has to be an outcode response, and we have to indicate that the client ID and redirect URI endpoint to receive outcode to access token. Scope layers, permission layers. This is the normal petition of layers. We have seen it in several attacks here in Spain. This is an example I came across too, that stole some money from a person by pretending not to be what it was. They pretended to be Spotify. They clicked on, and they were supposed to get 2 free months of Spotify. On this website, they do a redirect, which is until they're asking for the authorization of application to directly access the victim's email. If the victims click on that, it's done because they have been given all this code permission for the attacker to proceed. This is funny because if you don't have an open session, they ask you for access in the session is closed. They're asking me for my password. It's HTTPS in green Microsoft. How many times have you told somebody if it's green and HTTPS, okay, proceed? This is not phishing as such per se. You are giving Microsoft a password and to a user to Microsoft. This is shut down, but if it's open, let's see, depending on the environment. On the left, and not look user, we try to take permissions from him and to just on the left you see Spotify. By following the previous example, we find the IP details. We have to work hard on that, not to look at IP. It has to look like a strange Spotify alien path and strange domain.
We also have where you see the permission we're asking for, but it's quite common that the user, when visiting this page, just grants access because we're used to doing these things. To the right, you see an Office 365 account. When we ask for permissions from it, there's no logo anywhere. There's localhost there, but we could polish it a little bit more. And in the permissions, but this is in English, but since it's coming from Microsoft, everything is okay. We accept, and as soon as we accept, we are giving the auth code to the attacker so that they can get hold of an access token. As soon as you click, game over. No need to steal anything. Second factor for the authentication, nothing. It doesn't care about it. As soon as the user does clicks on this, the attacker will get the auth code, and from the auth code, as Pablo said before, we will build the next request, which is getting the access token. So, a request to Microsoft, which goes to a Microsoft domain where we need to tell it we want the authorization code. In this example, we give it our client ID, which is our application, our secret because we're authenticating with it. We give it the auth code that we got before, where our permissions were approved, and then we say where we want to get the access token. Okay? In Rect UDI. Once we send the request with all the correct data, the authentication ID, the secret and the auth code, we will get the access token in this format. What we get is a JSON web token. What is that? If you take a look at the second line towards the right hand side, you see a dot that corresponds to the scheme with a lot of A's. That part is base 64, and that's the header. From that dot to the next dot, which is 6 rows underneath it towards the central part, you have the payload. Okay, base 64. and from that dot towards the end you will find the signature. This can be taken. What do we find here? We find information like the scopes and who it belongs to, the access token belongs to, then dates, source IP, etc. Is this interesting? Well, sort of. By using that access token, which is quite long and split into 3 parts, we would need to include it in a header for authorization so that we can send it to the service provider in order to be able to use the functions and get information from that digital entity that we have in Microsoft in this case. Quite simple. Did you get it? Very simple. Let us show you the demo, which is quicker. Here we have the demo account for Office 365. This has a second authentication factor for the account. It's open. We have a one-time password with Google Authenticator, which is allowed, but that doesn't matter too much. So we'll go to tokens, where we have the tokens from our victims. We'll steal another one. So we just select an email address. The application will ask for permission to access your email. So how about an application for anti-spam? Something that can write, like Microsoft Anti-Spam Pro. With the Microsoft logo, this will be given to premium customers so they have less spam. Okay? Anti-Spam Pro at Microsoft.es, sender name Anti-Spam Pro, victim's email address, demo@epass.com, victim's name is demo, and now the application we will select. Since we have several ones here, we will go for Office 365. Have 2 APIs. We'll take the Office 365 API. We click on create, and if it all goes well, from our SAPPO platform an email has been sent that should get here if everything is okay. Right, there it goes. That's the email we got. Obviously we have designed it really well. It really looks genuine. There's no typos or anything. So here we have a link. That link takes us to this website. And in this big screen, this is what the user has to read. They need to understand whether they decide to accept or cancel. That's the only security mechanism. I know there's alerts there, there's warnings. You see them, yeah? The anti-phishing. So this time the user calls you telling you, oh, I've got this beautiful thing with a blue picture from Microsoft. It says log into Microsoft.com, HTTPS, everything is in green and it looks really cool. Well, as soon as they click on accept, they go to SAPPO, game over. You see the application and that's everything. We have redirected them here or to their mail. They will not see anything else. What do we have on the other side? We update, we refresh. This token is valid. It can be refreshed for up to 15 days. And since this is an Office 365 API, we can see everything. We can see the contacts, we can see the email addresses. 100% of email. This is cloud to cloud, okay? This is not going through the corporate network or anything. If you have an internal security network, it won't be affected. If there is a second authentication factor, it won't pay any attention. So here we see every single email message. Of course, they get invitations from the Anti-Spam Pro program from Microsoft. We can read emails, we can delete them. Our big friend Joseba has made an effort to leave a clear screen so that we can access the folders, the drafts, everything. And the most important thing here is that you can send email directly from here, Okay, we can go here. And correct me if I'm wrong. Yeah, the magnifying glass. From here, we can send email. Why do we have the send email functionality? Well, it's quite funny because in the scams we've seen, the attackers monitor your email, and when they see that you're about to get a payment for an invoice or make a payment yourself, that's when they interact with your contacts, sending them an email saying that they should pay the account number so that they make a transfer somewhere else. So here you could send an email to anyone. You could send an email to Chema at 11path.com. I'm giving you your cut. Hi Chema. This is so cool. This rocks. Whatever. We send, and that's it. That will be sent to another email account. Did you understand it? Through the token, you have access to 100% of everything. And it doesn't matter whether you have a second authentication factor. So, what happened beneath the surface? The user would have to go to apps and permissions, and here, after a while, they will see the application. It won't be there immediately. It's not there, not yet. We are capturing data from the user, but there's nothing in the environment. When the application shows, there will be details about permissions, not too much. And the funny thing is that we were testing the demo earlier today, and I don't know what happened, but one of our applications became an application for which permissions were not could not be revoked. So it was difficult to clean the system. But anyway, the application should show up after some time. Well, we'll see it later. It would look exactly as it looks here. App properties. If we go into details, there's not much. There's nothing specially detailed or striking. The second demo, let's do it with MS Live. All yours. So I can use your laptop. Let's follow the same procedure. Only this time we're going to use an application that will make the user give us permissions, Outlook in this case, to use the API for Live instead of the API for 365. Why? Because we can access SkyDrive, or OneDrive as they call it now, and that's interesting. So let us generate a new email. Let's keep things simple. An anti-spam application. Again, this is the email address. We customize it. It's Pablo. So we'll say, hello Pablo, you've got a new anti-spam pro application for your Outlook account. And that's the Live API. We send that email with some time. So we have the email here. We believe this. And we find this. A nice long list with permissions. We see that logo. That makes us feel okay. And here we see the HTTPS. Scopes will be seen here. I can enlarge that. Not the URL, you can click on it and drag it. Whatever, the scopes are there. You can believe me. You didn't blink your eye at the same time. We say yes. And that's it. Game over. Redirect to Outlook. I'm now protected against spam. This account has a second authentication factor, by the way. So we go to SAPPO, we refresh the page. We refresh. Give me a second. Now the second one is from this morning. Please bear with me. Sorry, we're not getting sound from the person not using a microphone. Maybe you didn't delete the app. Oh, there it goes. Yeah, the size of the table. So we have here the token. And we have the opportunity to see contacts. Doesn't seem to be a very sociable guy. And we have access to OneDrive, which is nice because he's probably a geeky type of character. In OneDrive, Joseba has put together a really interesting component. We can access the entire drive. Here, we can grab a document and download it. Okay, by using the token, we download the document. We have now stolen that document from this guy. So far, it's really cool. We could even have a function that downloads everything automatically and then empties that directory. But it's got another interesting functionality, which is the possibility to do a search for words inside documents in OneDrive. So we are looking for the word pass. It will then go into all documents in Microsoft Drive to find that text string. It will tell us, I found 2 documents. We were in the root directory. Those documents were not there. And when looking for pass, it goes to all the folders and it finds another document called Otro del Montón. We download that document. We open it. There it goes. And here we have a number of passwords. So we've seen the power. And the ability we have to steal files and to search inside the files, which is very powerful. So let's close this. Show this stuff about the application. So where is our application, the one that granted us the permissions? We go to account configuration. We need to go into security and privacy. Into manage permissions, so it's not one click away. This is very scary because suddenly Microsoft asks you for your password again. This is not phishing. So finally you get to the application and you find this. You find that you have all those permissions here and you can revoke them. Well, by the way, Chema, in the demo account, please refresh. This is interesting. It got there, finally. If you take a look at details, permissions are not available, and they will not be, because we've been working on this for some time, and during all that time, we haven't been able to see the permissions through Office 365. So application permissions will never be available. Details are not important. So what, should I revoke or not? I don't have details. I don't know what to do. Okay, that's it. So let's revoke those permissions for those apps. The cases I found myself, they'd done it for Hotmail. The application was Gmail accounts, and that was it. who on earth would delete an application called Gmail accounts or Hotmail accounts from your Hotmail account? You have it there, you don't know why, but you look after it like a bonsai. So you've got anti-spam and you've got a Gmail account. And the worst part is that if the victim or someone else ask the expert, they ask Clippy, the questions they usually ask are, well, you can imagine. The first question would, is this the official Microsoft domain? The answer would be yes. Is it HTTPS? Yeah, as well. Is it green? Yeah. Is it asking for your passwords? No. It is not asking for any passwords or usernames. Any alert in the anti-phishing filter? Nothing. Because as I said before, the anti-phishing filter is based on analyzing the URL, but there's URLs from Microsoft. Would you apply anti-phishing to the actual website from Microsoft? Doesn't make any sense, because this comes from Microsoft. And if you check everything that has been published by the media, and I'm not implying that they made mistakes, by the way, or that they gave incorrect advice to users, if you take a look at the recommendations from the media, everything they say is to go for those questions and get an answer. Anyone can think of anything else? Sorry, no sound. Application permissions. You watch Discovery Channel, I'm sure. We don't watch the same stuff. Application permissions in Android. Right. Not in phishing. Not in phishing. So as it happens with all of these pieces of advice for phishing, this becomes like mum, when mum wants to help you. I sent you an email, I sent you a message, you left your phone at home. Well, it's very similar to that. Sorry, no sound from people not using the microphone. Yeah, there's a padlock in green, and it's HTTPS. There are solutions around this. Well, there are some. Not everything is lost. One of the easy solutions, or difficult, depending on the way you look at it, is by using encoding, using encryption, using a public cloud. All the data that is stored in the public cloud are encoded using a gateway device. They act as if they were a proxy, which is part of the organization. So when you connect to Office 365 or to Gmail or to any other provider for public cloud services, what this device does is decoding the contents, and the storage of that contents is in the provider of that public cloud, but it is encoded. If you want to decrypt it, you necessarily have to go through the gateway. In this case, we have a platform for public cloud encryption, and indeed, you get to your email, but this is completely encoded. It only leaves a few fields unencoded, like the address of the sender, but everything else is completely encrypted and protected. So they get to the place, but they cannot access anything. And then there are solutions that we should implement in companies. I mean, checking logs and checking what is happening in our network is cool, but we really need to use cloud-based log solutions that allow us to establish correlations with the logs from the cloud providers we're using. So we must use a cloud that uses an API to connect to the logs of our public cloud service providers, Azure, Dropbox, or whatever, and correlate everything with the network. Something similar to what we have been doing with the IDSs inside the network, but now we're using a public cloud. Okay? Things like Log Trust, which is Spanish, or Elastica from Blue Code, which does this. It connects to all repositories, public cloud repositories, it extracts the logs and then correlates the data. Otherwise, it's impossible. And then it would be great to have a second authentication factor for apps, so that we may decide when to grant permission and when to reject it. In this case, you've seen that this can be refreshed. It's quite easy for an attacker, if there's no control, to extend it over time. We can keep refreshing it for days and days and days on end and monitor the email of our victims. And not much more from us, as simple as this. Since we did quite well in time, if you have any questions.
Preguntas.
Questions? Have you tested it with some L2? Well, we've tested it for the things you've seen, Roman. There's a lot of companies out there that are probably having a hard time by looking at this. I'll tell you about the next apps downstream. Some L2 would be nice to see how that federated model works. Questions? I don't see any hands. There's one up there. Another one down here.
Venga, primero aquí abajo, que ya tienes el micro.
This one here. Congratulations for your talk. I found it really interesting. This is not a mistake in implementing on the part of Microsoft. Sorry, we're not getting sound from this person. He's talking too far away from the microphone. Well, this is not an implementation error from Microsoft. It works exactly the same in other environments. It works exactly the same for Gmail. You know that there is quite a controversy about auth, but it operates exactly the same way everywhere. It's granting access to the properties of an IDP. With OpenID, it would be exactly the same. It would depend on your implementation, and obviously the permissions and the scope that you want for that authorization. But every case is different. We've been taking a look at the main ones, but there's quite a few out there. Quite a few services in the cloud that do similar implementations. In ERPs, in CRMs, those systems allow you to do something very similar. Implementation is relatively different, and what we have been doing is playing around to see what we can get out of them. Congratulations for your talk. One question: if you encrypt the content in your public cloud, wouldn't you lose all the functionalities, searching functionalities that Microsoft gives you? That's question one. And question two, wouldn't it perhaps be better to ban the installation of applications that are not approved? Well, question number one, whether you lose search capacities if you encrypt the contents in your public cloud? No, you don't lose any functionality. We have everything encrypted, and search functionalities are still there. Remember that this is reversible encryption, so that you can keep all the options for these searches. And about banning, preventing the users from installing applications, I'm not sure the console gives you that option. You mean the administrator console in Office 365? The console from Live doesn't have it, but in Office 365 I don't think there is such an option, but I'll check it out. If you mean amputating the hands of a user, 100% in agreement. Last question over here. Congratulations, Chema. About encrypting, you can still search when the content is encrypted. Yes, in public cloud you can So that means it is not encrypted in practical terms. Yeah, because you do the search from the gateway. But as I understand it, there must be an upper limit to the number of queries that you can launch. You can launch a maximum number of searches, yes, as with any search engines. But is there a limit based on unit of time, per day or per month? I'm asking. You're asking because of Microsoft? I think you can search based on any string of text. What this does, if you have an encrypted content in a public cloud, it ensures that that encryption is reversible. So the indexing functionalities you don't lose, because you're indexing the encrypted content. The gateway knows how to encrypt the string that you're using for your search. So it looks for the encrypted data. What I mean to say is that based on the results that you got, you may infer the content, break the encryption without having access to the content just by looking at the results of the search. Yeah, but in order to do the search and see the results, you have to go through the gateway that encrypts and decrypts. If you went the other way around and did a search, you would have to do a search of encrypted data. You wouldn't know what you're looking for. Now, is there a possibility to do a cryptographic attack on a reversibly encrypted data? Yeah. Someone can get the algorithm for the public key for that public cloud and search based on an attack, launch an attack. But here we're talking about much more complex protocols. Like SSL, things like that. Of course, cryptographers take care of that. But nowadays, this is a very effective solution against any attacker injecting an application to steal data from you. Okay? Thank you very much. Well, thank you. So, a 15-minute break. 15 minutes. We'll have the last talk